Welcome back to Workshop Friend and part 2 of making a rear tool post for a Colchester Student lathe. Today we're going to finish off the base and start working on the column. So having more or less completed the base, I'm now turning my attention to the column. This is made from a piece of 3-inch diameter, approximately 75mm free cutting mild steel. So I swapped the bar end for end, and now facing the end which will mate with the base. So instead of taking a number of shallow facing cuts, I sometimes find it quicker to take deeper stepped cuts in the active direction like this, which better utilises the geometry of the tool. The dimension here is 5.035. I've cut it off at 5.05, which will leave a little bit of material for facing up afterwards. The other thing you might notice is I've resurfaced this. I noticed that this wasn't quite square with the axis of this. So in this setup I've got the center in here, and I clocked up this to make sure there was no, everything was running in line. So when I did that, I found that face was out, so I just re-skimmed that. So that's why the surface finish is not as it appeared before in the other lathe. Now I know on a deep cut there's quite a chance of the parting tool wandering slightly offline, even though it is bang on square with the axis. So I'm allowing that little bit of extra so I can go in and face it and not end up oversized. So that's 5.05. I just engaged the back gear. I don't normally have to use back gear on this lathe. I normally find I can manage with the pulleys with my variable speed drive, but this is really pushing it. I hadn't realized just how noisy the back gear is. So as the diameter got smaller, I was able to disconnect the back gear and use the belt drive. Since last time this setup resulted in the work not being held squarely, I've deliberately pulled the work out of the jaws, so that gives me the flexibility to just tap it into line, as you can see I'm doing here. I think that indicates that my 4-jaw chuck jaws need to be reground. I'm not quite sure this setup is viable, but I'm going to have a go. So I've got my bar upside down in my 4-jaw chuck on my rotary table, small rotary table, and I have centered the bar on the axis of the rotary table on this boss here, because that's what really matters, or the recess that it fits in on this plate. So I really want to measure off this boss. So I've done that. That's running true. And then I know the diameter of this. I know the PCD, which is well, the radius actually, which is 1.123. I've got a 1/4 inch peg in there. So from that, I've adjusted my quill and just rotated it on the head here until the slip gauges just go in, lock the head. Just reminding you, this is not a milling machine, this is my pillar drill, but it's the only option I've really got. Well, it looks about right, so I think we'll just continue. So I just started the threads in the pillar drill. I'm taking it over to the bench now just to finish off the tapping. It's more convenient to do it there. This is where an airline would be useful, but in place of that I'm just using this wire to remove the swarf and the tapping compound so that I can successfully get to the correct depth. Now I wanted to pause for a moment and just check how accurate that setup was. It's a relatively small 4-inch rotary table, and the height of this is just over 5 inches. And just sweep round and have a look at the setup. So the height I'm talking about is the height above the table, because the 4-jaw chuck sits on top of it, and the total height is just under 7 inches. So 7 inches on a 4-inch table. That's what I'm referring to. So what I was interested in was the spacings. Of course, I've screwed these down so that there isn't a lot of movement. So I measured all 4 of these and recorded them, and also finally removing one of these screws at a time to measure that dimension and then again in that direction. And what I found, to my great surprise and encouragement really, this was 1.953 inches, 1.952, this is 1.952, so there's just a deviation of 1 thou there, and the most out was this one here, 1.956, and across the diameters 2.607, 2.606. So I was very pleased with that result, and it's much better than what I was able to do by eye. So from that I've determined that I'll easily get away with a letter X drill. So an X letter drill will provide plenty of clearance, but what I might do is just try and go for W first, open these out, try it, and if it doesn't work I'll go ahead and use the slightly larger drill. These are just under 3/8, I mean they are 3/8 threads, but 0.373, and I reckon if I go for a 0.386 drill I might get away with it. If not, I'll go up to the 0.397. Well, I've done a trial assembly in all 4 positions, and I'm glad to say that even with the smaller clearance using the W drill, that I can bolt it up in all 4 positions. So that's encouraging, because that means that I have a clearance over the bolt of only 13 thou or 6.5 thou on radius, and it all goes together. So that's good. So not such a bad result after all, despite the slightly disappointing results for the layout by eye on the base plate. Now I'm getting set up to counterbore these holes. I've already done one, which I actually did with my boring head. I was actually planning to do it this way with flat bottom drill, and I've used this method in the past very successfully. So I've got a pair of drills here. One's a standard point and the other one I just ground flat. So you're going with a standard point to depth and then finish off with a flat bottom drill, and that works very well. But I didn't have any drills large enough for this, and I need a pair as well, so that was quite unlikely. So I'm actually using the mill. I'm setting up, just lining up over the hole with my DTI holder here, and I've just lined this one up, and I'm going to take this off, put the cutter in, which is just a flat bottom cutter. I've lined it up with a square so it's flat, and we'll just go down to depth and counterbore these holes. I could have been a bit more ambitious with the cuts. As it turned out, I took 3 cuts for each hole to bring to the final size. I'm marking out now for the 5/16 UNC holding down bolts. So I'm just using this center to pick up the center dot, which you saw me enlarge and position as best I could by eye. And then I just lock the quill just to provide a bit of pressure while I tighten this up. Now sometimes the work slips, and I should have put a piece of paper underneath here to stop it from slipping, but I forgot to do that. If your bolt's not vertical, then it can cause the clamp to slide slightly and move the work. So I'm just being very careful here, doing it from a couple of angles. That looks okay, but even having done that, sometimes when you put the first drill in, you can see it wasn't quite right. Incidentally, my drill is wobbling around a bit because I haven't properly patched it up on my uneven floor. One of those jobs yet to be done. It's because I've been moving things around in the workshop and I haven't really decided on the exact final position, so but I will get around to that. Okay, let's give this a trial run and see what happens. See if this, put it on the high speed, see if this is on center. Right, that's far enough. We're going with the next size of drill and open this hole up. I've got all my drills lined up on the shelf next to the drill in order, and this one will take right through. Okay, and I get set up for the remaining two holes, but I'm going to do those off camera so I can listen to the radio at the same time. Oh, just a word on why I marked out and drilled from this side, which is actually the bottom. The reason for that is that sometimes drills wander slightly, and if I start from the side which is going to be mated up against the other component, then I'm putting the hole in the best possible position. If it wanders, it's going to wander at the top side. So on the top, what we need to do now is to scallop this out, and we've got these recesses here to allow the head to sit down lower. Now on my GA I actually had the head slightly up. I might review that. I might just bring it slightly below the surface. I'll decide that as I go along. So what I'm going to do now is just apply some layout blue, mark out these features, and then take this over to the mill for milling these features out. Incidentally, another reason why I drilled the holes first is because drilling is a very efficient way of removing material quickly. So by drilling all the way through, I'm actually reducing the amount of material I need to remove on the mill. Okay, I've mounted the column on the base. The base is now completed, and I've orientated it. Of course, we can go in 4 positions, but I've orientated so that these unsightly marks, which were a mistake on my part, dig in, are on the side that's going to be removed. And what I'm going to do now is mark some of the edges that I'm going to work up to. Basically, there's a slice that comes off the front here, and I've got the dimensions here. So I need to take 0.4 off this face, and I'm going to mark the lower edge, the sloping area here, also the corner, because I'll probably use that in the milling process, and then I'll turn it round and we'll just mark the chord on the top.